where it's 0 with undefined intervals, then you make a little sign chart.
That's it.
Oh, beautiful.
Yeah, it's really easy.
Oh, but sign chart related. We take the derivative and then
Right.
the derivative.
Is this exam 6?
Oh, the first group.
Oh, what?
Is this exam 6?
What?
What are you talking about?
Like,
This one we just took was exam 7.
Oh, yeah.
It's like one number ahead because we took 2 exams the first week.
Well, yeah, I knew that. Yeah, it's all from last year. Yeah. He did a pretty good job teaching us. Yeah. That's really hard fast. No, not really. We were at so once we start to get into like intervals and all that stuff.
I believe you.
Oh, thank you.
I didn't think that.
Oh,
It's fine.
are you alone?
okay, let's do a related rates problem.
I just forgot what you taught us last time.
Yeah. So it says use differentials to approximate how accurately you should measure the radius of a circle in calculating its area. Okay. So the problem tells us of a circle. So the first thing we should write is
The equation.
the equation. What's the equation for the area of a circle?
Pi squared. A equals pi squared.
Yep.
Yeah.
Okay. That's the first thing you should always write. Recognize what it's talking about, then write the equation. If it is a sphere, what's the area of a sphere?
Like 2, 4
4 pi r cubed squared.
What?
The cube.
The cube,
Yeah,
the volume is 4 pi r cubed.
Oh,
Wait.
But that's important to know, so let's look up those equations.
yeah.
What?
What's a sphere?
Probably not a sphere, but let's look at those anyway.
If they did ask us about a sphere, would they give us
I don't know.
Probably not.
We haven't done 3 measures yet.
So area is 4 pi r squared.
Will we get into 3D stuff on the end of this?
Yeah.
I just want to work.
Yeah, I think you do get into like area of a cylinder and stuff using integrals. Volume.
No, I was talking
Area of the sphere?
about intervals like
4/3.
area.
Oh yeah, this is
Your
4/3.
regular sheet.
Oh, it's just pi squared for both.
Area is, oh sorry, there should be a 4. There we go. Area of a sphere 4 pi r squared. Volume is 4/3 pi r cubed. So I don't think you will get a sphere or anything like that, but it's good to know the formulas. But they could do a cone. What's the formula for a volume of a cone?
You mix the triangles and circle together, don't you?
Like 1/2, 4/3 pi.
It's 4/3, I believe, or 1/3. It's 1/3. 1/3 pi r cubed. Yeah, I think it's squared times height. So to give you something like that, if you don't know the equation, you're already screwed. But it's also good to recognize that there's 2 variables in this. So then when you do the differential, you know you have like r prime, h prime. This is just with r, this is just with r. So area of a circle is just pi r squared. So if I were to take the derivative of this, what would it be?
2 pi
dA is equal to 2 pi r times dr. Why? When we take a derivative, we take it with respect to time. or that's what,
Time?
because related rates are with time,
Oh,
okay?
that's fine.
So it's dA dt. So we're taking the derivative of this function with time, and then we do the chain rule to get r. So it's dr.
Okay.
So you could think of it as like dr dt, but they both have dt, so it doesn't matter. Okay? So just remember, the derivative of a is dA, and then for each variable is dr. So if we had an h here, it'd be dh. And the problem could say something, approximate how accurately you should measure the radius of a circle, calculating the area within plus or minus, let's see, plus or minus 4% of its true value. Do you guys do stuff like this? Like problems like this, sort of?
No, we did in the class.
Not in class or in class? No? Was it in homework and stuff?
We haven't done that.
That's in the homework.
Okay.
It's,
So
We haven't done
this could be on the test. I'm just going to go over it. Okay?
Wait, so
Wait,
what
so-
is this asking?
So it's asking us to find how accurately you should measure the radius
to be within 4%.
with that to be within 6% of the actual value of the radius. So 4% of the radius. Okay?
So, yeah,
Sorry,
I got that. I understand.
not the radius, the area. So dA over A is equal to plus or minus 4%. Wait, maybe I do think I'm looking at the wrong session. This-
Daniel. I understand what you're
Wait,
asking.
are you sure that was in the
I don't know
homework? What percent?
What?
No.
We don't know.
I don't know.
We haven't done what we'll be asked to do.
I think. It's,
Yeah.
I think we're fine. I mean,
Because
Number 10. Gosh.
this should be part of the stuff that they can test you on. Let me just say that.
okay.
Well, why?
It's gonna be on the video.
Yeah,
They do all breaks on video,
so that's why.
so you can watch it every night.
Okay, so this is probably like on the video, so let me just rephrase it to make it more understandable. Because, okay. So this is what the problem actually states, or they could state. Use differentials to approximate how accurately you should measure the radius of a circle to be sure of calculating its area within this range, okay? So you want the area within this range. So the dA over A has to be plus or minus 4%. Okay? So then this is dA, but that is dA over A. So we can do dA over A is equal to 2 pi r dr over pi r squared equal to, we get 2 times dr over r equal to plus or minus 4%. Okay? Or we can write it 0.04. So then dr over r is equal to plus or minus 2%. This tells us that the radius we need to measure within 2% to get the accuracy for area within 4%.
We did it. That was it?
Yeah.
Oh, it's beautiful. Okay, so
But-
you take like the derivative, and then you have to multiply it times like the dr or whatever variable you have.
So the first step, yeah, is
Divide
finding
it by
the derivative, okay?
That's the differential.
Yeah, this is the difference. This is what they'll give you. So, and they told you it's for area, accuracy of area. So it's dA over A. So the change in area over the area. And then you simplify it and you get dr over r. I don't think I explained that
So-
clearly.
Why wouldn't it just be R?
What?
dr over R?
Does that
Yeah.
stand for change or like accuracy?
Yeah. This stands for the accuracy that we need to measure the radius of a circle with. That goes back to linearization and those sort of rules. Let me open that up again.
Oh, yeah.
We're gonna go over that because I know everyone probably forgot all that.
We had a study. You said you did.
I did.
You did, I did.
Obviously. Let me use it like a constant.
So this is when I talked about relative change and when I talked about relative change in the last video, or those sort of things. Do you guys remember that?
How was that?
Okay.
I remember you were a bunch of formulas that we didn't remember.
This is objective 8, just letting you guys know.
Thank you.
So I'm gonna make up another example because it's good. Okay, let's do. Let's see if this one will work. But what's the formula for area of a triangle? Yeah. Let's do area of a rectangle. We'll just do a square
Okay.
with one variable
So,
because I'm sort of just making this up. So the dA is equal to what?
to be prime.
And if they told us that we want the area to be accurate within 10%, okay, what do we do?
Divided.
Equal to, set that equal to 0? Or no,
You divide by the
A.
original function.
Yeah.
Divide by the original area to get the change in area, sort of.
Okay,
My terminology is probably not right, but
that's excellent.
this is b squared at the bottom. This is equal to 2 db over b equal to 10% plus or minus.
Wait, dB, is that the derivative of B?
The same as b prime.
Yeah.
Okay, that's all right.
Should we use db instead of b prime?
Yeah, I just write it in this format to get that db over b or something. For the accuracy, we need to measure the base is in 5%. So it's not that tough, but this is a critical step in understanding. Okay? And let's see if we can do it for a triangle. Like,
We're always gonna be like take the derivative and then you like divide by the original.
Yeah.
Okay.
to get dA over A and dB over B,
You're
or
gonna give us two variables.
yeah, we're gonna do that right now. So the area of a triangle is 1/2 base times height. All right?
Yes.
What would the dA be?
Now we have dB and then HDA. Oh, Mark.
Yep. So it's dB times H plus.
Plus.
I'm gonna call it someone.
H.
Brian. Who's Brian?
Why did you pick the one name?
to get dA over A,
Yes.
which is 1/2
Wait, what's our?
base times height. I'll tell you guys later.
Oh, okay,
So-
looking forward to it.
So the first step is just learning how to simplify this. Okay.
Oh,
People can get confused in the math, because they can get tricky sometimes. So in this, the best thing to do is just to separate them into two fractions. Okay.
okay.
So then the 1/2s cancel out. We are left with dB over B. You guys see that? The 1/2s cancel out in all of them. dB over B, and the h's cancel out on this side, and on the right side we have dH over H. Okay. In this sort of a problem, they would tell you to measure the area within plus or minus 10%, and the area, and then the height, let's just say within plus or minus 5%. Okay, so they would give you two information. So-
For DB.
So then, how accurately would we need to measure dB over B? That's equal to minus 10% minus what's that? 5%. And the end it should be 5%.
Oh, so you just like plug and check.
The main place that people get confused is this step. Okay, that's where people get confused with. They sometimes don't separate them right, or they take the derivative wrong, so they don't get dB over B, or something like that. So then they don't know what to do. And there could be times where we could have had, say, a B here being multiplied, right? And then they tell you when base is 5.
Is there a rule to always get it like DB over B, like derivative of variable on the same?
Yeah. So they probably tell you one of those. Or they could tell you to find the dA over A when you've measured the base and the height with that much accuracy.
Thank you, Nancy.
Yeah. Let's do another related rate. So we are looking at a spherical, and they would give you the area formula, as I check now. So this is of a spherical sphere. Okay.
Well, we have to know that, or is it like?
No, they'd give you that. Yeah, I just looked. They'd give you that. So let's say the numbers aren't going to work out since I'm making this problem up.
Oh.
But
Stick with 8.
say this is a spherical ice and it's melting. Okay. So we need to find the rate at which the radius is melting when we know the volume, or dV, is changing at 0.2 centimeters, and when the radius is 0.05 centimeters. Maybe that'll work, maybe. Let's make it a 0.05 pi.
Okay.
Divided by pi.
You're like, I think I can.
Square root of pi.
Oh my god.
I'm just trying to make it easier so the numbers work out. Okay? So 0.05 divided by square root of pi. centimeters. So this ice is melting. What is happening to the volume? It's getting smaller. So is this number positive or negative? Negative.
So we need to know.
Yeah, you need to understand what that means. So it's asking us for the rate at which the radius is changing. So what do we need to find?
D R R.
No, it's just dr. When you look at accuracy and stuff, then you do dr over r. That's the difference, you guys see. Sorry if it's too slow. So what's the first thing that we should do always? The equation.
Do DB over DR.
Yep. Well, not over dr, but with dr. It's with respect to time, because
Oh.
time is passing.
That's why we still have to put that R prime in there.
Yeah. Okay. So we rewrite the formula. We can just go dV is equal to what?
4 pi R squared on 5.
Yep. Do you guys see how she did that?
Yep.
Because it'd be 4/3 times 3 pi r squared. So the 3's cancel out, so this is it. And then, so this is related rate, not the accuracy. Okay?
Are they kind of in the same bundle?
Yeah. So what do we do here? We know some information, and we're trying to find some information. We plug it in. Most of the time, it'll be just plugging it in, and you'll have one variable that you're looking for. So it's negative 0.2 equal to 4 pi times 0.05 over square root of pi. And that thing is squared, dr. Okay? So it's turns out to be negative 0.5. Is that right? 0.2 divided by 4. Is it 0.05? Yeah. Negative 0.05 equals to pi times, what's 0.05 squared? 0.0025 over pi dr. Okay? The pi is going to cancel out. That's why I made it square root of pi.
Wait,
I
how
knew
do
you
you
were looking at
What?
receive negative 0.05?
it. He divided by 4.
Divided by 4.
I just feel weird if they're like it's 5.2 centimeters, then I'm like changing the information they gave. But I guess they didn't write DV equal.
No, it says it's decreasing. Yeah, it's decreasing by 0.1, or we use 0.2. So it's centimeters cubed actually.
Why isn't 0.05 negative? Well, that's just the rate, it's not the way it's changed.
No, you may have a point there.
I don't know. You said that's the radius, and I want to know how it changed.
Oh, yeah.
So dr is the rate and the radius, how the radius is changing.
We should get a negative dr because it's getting smaller.
It's getting smaller.
And then if you don't, you mess up.
Yeah. So dr, or I'll write over here. Dr, therefore, is equal to negative 0.05 divided by 0.0025, which I probably don't know how to do in my head. It's 0.2.
I had it, that's I have one.
I got it.
I don't know. What do you
The quarter.
do?
20.
Yes, negative 20.
Yep. Negative 20. Thanks.
I would be so happy if they give us this exact problem on the test if you're made up information.
No, that's not. So did you guys see how we did that? It's not really tough at all. It's just they'll give you this formula. Again, the main idea is knowing how to differentiate that.
So when they ask how something's changing, they always want DR. And if they want to know the accuracy, then you want
Yeah, then you should go with R. Yeah. Let's do.
Wait, what was that? You said accuracy of all?
Then you should divide it by the formula. Like we divided by 8. So now let's do some linearization stuff.
Wrong?
So f of x. Let's do.
He has a problem for you.
Do you have a problem?
Yeah, let's see, negative f of x equals negative 3x cubed.
Negative 3x cubed. Is that it?
X cubed minus 5x plus 6. For a equals negative 2.
For what? A?
Yeah.
What do you mean A?
X equals a equals negative 2.
X of A. Is that what you're saying?
X,
They present it to us as f of a minus f prime of a x minus a. So
Yeah.
Is that how you write it?
Yeah.
Yeah. It's,
And why are you saying X?
the entire question says find the linearization L of x at x equals a. For that problem, a equals negative 2.
Like that?
Yeah.
Okay. So we need to find linearization of X. So what's the formula for linearization?
f of a. What's it? Plus
F of a
plus f prime of a.
x.
There you go, Brian.
Say that again, guys.
F of a.
Yep.
Plus f prime of a.
Yep.
Times f minus a.
Yep.
Plus
All right. What is the function with negative 2 in it? That'd be negative 3 times 2 cubed minus 5 times negative 2 plus 2. Right? What is the derivative of it? What is the derivative of this function?
negative 9 minus
Yep. Negative 9x squared minus 5. Okay?
Wait, is it, you have a negative 2 and a positive 2 on the linearization whenever you plug it in.
Here?
Yeah.
Yeah, there we go. Okay. F prime of A, we know that. What is A? A is negative 2. Times what?
x plus 2.
Okay. So L of X will equal something. Is that the whole problem?
Yeah. Yeah.
24.
You have to approximate to some value or something?
I think you just have to just find. There should be like some type of line.
Yeah. So once you solve that, you have X in the function. Yep.
Okay. I'll do that then.
So the main idea with linearization is approximation. All right, guys? You will get some equation with an x plus something, right? So if I told you find when x is equal to say 4.9 or something, you'd know to put that in and solve it.
Into the linearization, what would the question be exactly?
So it could say approximate a weird value. So normally, yeah, so it could say like square root of 5.573 or something. You can't put that, it won't be easy to do it in that original problem, but if you do it in linearization, it's easier. And the problem they'll sort of give you guys, f of x could be like the square root of some number. Okay? Like the square root of 5x plus 10 or something. Where when x is the square root of 5.5, it'll be like, it'll get confusing. Yeah. So it makes it easier when we linearize because then we get a linear equation.
There was something on the one about like it would give me 4.6 and you're just supposed to make it 5. Is that a thing or no?
What do you mean make it 5?
Like, I don't know, they gave you a value, they wanted you to just make it the closest number from I probably
I
don't know.
But that's how you would do it.
So I did hear it.
So they say approximate what the
Okay, so I'm gonna write an example, which will make it easier to see it. So say we have f of x equal to the square root of x plus 1. Okay? And you are told when x is equal to 5, or in this case, a would be equal, let's just do a is equal to 5. Find the linearization of that. So then you do the prime and stuff. What's the f prime of x? 1/2 times, right? X plus 1 is make 1/2. When a is equal to 5. I love x. Just plugging it in, we'd have f of 5 is square root of 6 plus, or f of 5 into the f prime equation. That would be 1/2 times 6 to the negative 1/2 times x minus 5. Okay. So then that's square root of 6 plus 1 over 2 square root of 6 times x minus 5. Okay? This told us, okay, this is what you were trying to get at. Approximation value when a is equal to 5. Okay? So what if we have an x, or let me think. When x is equal to 6, approximate when x is equal to 6. Okay? Sorry, square root of 6. All right? Can you put that in directly right there? Not really, right?
you could but be strong.
Yeah. So this is also equal to the square root of 5 plus 1. Okay?
Oh, square root.
Sorry. Well, x will not be. So the problem will say approximate to the square root of 6. Okay? You'll be given this. You know this is equal to the square root of 5 plus 1. Okay? When you convert it to that, this 5 is your x value. So then we just do L of 5, that's square root of 6 plus 1/2 square root of 6 in the denominator, 5 minus 5. Good. It's square root of 6.
So, we're supposed to use what they wanted to approximate to determine the x value by using it in the original function, then plug it in linearization.
Yeah, so it just happens so they turn out to be the same.
So like if they say approximate square radical 6, they don't need plug in radical 6 for x in the linearization.
Yeah.
You have to.
This approximation is equal to that.
Okay.
This approximation means that the function find when the function equals that find something. Hold on a second.
You said radical 6 equals radical x plus 1, right? And then you square both, you have 6 equals x plus 1.
Yeah.
And then that's how you know what to plug in.
Yeah, because you convert it back to this form. You make it look like that form.
Mm-hmm.
So you guys know the steps, but I don't think I'm explaining it clearly. Because they'll make an example that'll work, but I can't really do that.
Ours didn't work.
It did, but we got the same thing, which is fine. So in the end, the square root of 6 is approximately square root of 6.
Oh, thank you.
Wow.
So that's what's supposed to happen. You'll get your answer will be a value approximately the original. So let me just say the steps again. You have f of x, you find the linearization equation of it, you're told something to approximate with, so you try to find x by manipulating it into the original f of x. And then you plug that x value into the linearization equation that you found.
This is called approximation.
Yeah.
And linearization.
Yeah, those go together. And then we'll move on to, you guys remember Newton's method for iteration of an approximation stuff? You will need to remember that. We'll do a problem.
I should probably watch the video.
Me too.
I love watching that.
I like how in one video it's just saying
Well, like, the entire time that Dr. Tal's talking, she's like, Dr. Wilson's like,
It's the same.
like, why can't they teach us stuff in class?
There isn't enough time.
Well, I mean,
Luckily, there's
then expand the units then. I mean,
Well, how did they do it in the 70s?
Yeah.
well, actually, my uncle was in Sweden. They used an abacus.
Oh, God.
Yeah.
To do what?
Like a slide, whatever you want. Slide for calculus. I don't know.
So let's say f of x is equal to,
It's, I think it's
What is that? When you said abacus, I was talking
that's what they had to use.
what is f prime?
Yes.
So we did the first part.
Yep. Okay. So let's say del xo is 1. Do you guys remember Newton's method formula?
N x sub n plus sub x sub n plus 1 equals x sub n minus f x sub n over derivative of x.
Girl, you so smart, you memorized that. Wow.
Yeah, so
It is.
so
And they give you that stuff. Okay.
They give you that?
They give you that?
I see that there, but don't take my word on it just yet. If it's on a practice exam, then they'll give you.
How do you know if it's on the practical? Yes, you put it up. Yeah. No.
So the first define x1 is just a function with x. Oh,
What does x sub 1 represent? The linear.
the first
What is x sub 1?
approximation, maybe.
How do you find it? Oh,
We found all the information that we need. So xo is 1 minus, when you plug in 1 into that original equation, we get 1 minus 4 plus 4 all over 2 minus 4, which is 1 minus 1 plus 1 half. And then for x1, that would be, x2, x1 minus f of x1 or f prime of x1, which is 3 halves minus, all right, 3 halves into that original 9/4.
so you just keep going?
Yeah.
For how long?
Well, like they'll probably just ask you up to x2. So 6 plus 4 all over 3 minus 4. That's going to equal some number.
So what's the point?
Yeah,
It's a different way of approximating.
So, what does x1 and x2 represent? What are they?
An approximation value.
Of what?
So the more you do this, the closer you're going to get to the actual value.
If they just say use Newton's method, I should just plug into it. 'Cause I
Yeah.
don't quite understand what we're.
Again,
We did the linearization and then we like did the approximate. So.
It'll be on the videos,
Okay.
but it's the more you do this, the more you're going to be closer to the value.
Okay.
And the value of 1.
There's one of the homework that's like this, and it's x of n plus 1 equals x of n minus x over pound of x. It's asking for x of n plus 1, and like the answer is -2 x of n.
Then negative 2xn. Then you weren't told to find xn, they just wanted you to leave it in the problem.
What do you leave? What the problem? X of
The xn value,
so,
like you could have found, or they didn't give you the xn value, so then you just solve the thing without that value, and that's what it's equal to.
and like for the f of x, you like put in a value for it.
If they give it to you, do they not give you any value?
If x of sub 0 equals 1.
Yeah. And they give you that equation that you would use, right?
Yeah,
What equation did they give you?
x to the 1/3.
Can you come here? Yeah, that's this.
So what's the answer is 23rd by 3/4.
Why not?
Okay, thanks.
Yep. So So you have f of x. So you have to find all of these, right?
Yeah.
They don't give you an xn value. They give you an x of o value, which is what you plug in there. So you never know that value. Okay?
You plug in the 1 into here.
Yeah.
But you keep the x in.
Yeah. Or
Sorry, did you want to get food? We can get food tomorrow. Alright, cool. Are you gonna drink some more?
yeah. But then you
Oh, you
should,
have
how
to.
do you have negative 2
Okay, so
times
you
x and
That's the answer.
oh no, they just want you to simplify it. Okay? This is without any numbers.
Alright.
So you're simplifying what?
So this is just x to the 1/3 divided by 1/3 times x to the negative 2/3. Probably.
You get like try right here and get like xn minus 1/3 x.
Well, it'd be that would travel up, making it a full on x. So it'd be x to the n minus 3x, making it
Yeah.
a negative 2x.
But x to the
That
n
works
minus
out.
3x.
That works out. I'll do that problem here. So it's
X to the n minus 3x equals that.
x to the n minus 3x to the n.
Oh, you're plugging in x to the n.
Yeah.
Okay.
I have no idea what's on juice.
So wait, let me just write this down. Right. If we are to find x to the n plus 1 without having any xo value, what would we do?
You got to know.
We have x to the n plus the function divided by the derivative of it, right? And then we simplify. So this is sort of like x to the n itself. We get x to the n plus 3. Is it a minus here? Yeah.
Yeah.
The 1/3 becomes a 3. This goes up, and we're left with x to the n minus plus minus 2 x to the n.
How do you turn the x into 1/3 and the 2/3 into x then? How do you know that?
This is x to the 1/3. This is negative 2/3 in the denominator. That goes to the top times x to the 2/3. We add them.
So how is that x to the n not just
Because we're not giving any x values. This is just working purely with numbers. The starting is x to the n. And then they tell you, what if x sub o is equal to 1? We plug in 1. Okay? If they wanted x to the n plus 3, the equation would be negative 2 x to the n plus 2. You guys see how this works too? If they wanted x to the n plus 3, the equation would be negative 2 x to the n plus 2, because it's 1 unit lower. So then we need to have found x to the n plus 2 by doing that already twice, and then finding s to the n plus 3. That's the last problem or something in your homework. You guys all good with that? No? Okay,
So you just do it again and then you should know that it's n plus 2.
this is x to the n plus 1 equals to negative 2x to the n.
Okay.
Okay? When you're working with n and n plus 1, right? If we want n plus 2, we move the n by 1 unit up. So then this would be n plus 1.
So you don't have to do that whole process again, you just change the n value.
So this 1 unit lower. It's like with series and stuff.
No, we don't learn that again.
Use that in calc too.
What?
Series.
Series?
Yeah.
Yeah, that's real girl. And then,
So I'm going to erase this and then quickly do one more f of x problem, which I think is important with like df.
Daniel, how many weeks in the summer do we get off? Do we get like 2 at the beginning and like 2 at the end?
You get like 1 at the beginning and 3 to 4 at the end. Like full 4 weeks afterwards.
Okay.
Okay,
A
so
lot of people just stay here.
yeah. F of x is equal to, let's do 2 over x plus 1. And they tell us change in x is equal to, which we know is equal to dx. And then we can make that number to be, we'll just do 1/4. So change in x is 1/4. So for A, they said find change in f of x. What is that equal, or what is this equal to? What's the formula?
And finalize that initial.
So it's f of x, right? Actually, f initial plus change in x minus f of x initial.
Is that X not? Is that what that is?
What? Yeah, x naught. I explained this to you guys last session. You guys need to know this. And then it's just plugging and chugging from there. Did I tell you guys x now?
No.
Let's make x naught be 2. Or let's do 1. That'll make it easier. So then we have f of 1. It won't be easier. Right?
Oh, you are kind of doing a finalized definition.
Yeah, but this one has that change added to it minus the f of x.
Yeah.
Yeah.
That's like what you, yeah.
Yeah. So this is 5/4. So we have 2 over 5/4 plus 1 minus 2 over 2. That is equal to, what is it equal to? I'll just wait. You guys want to do it? What's 5/4 plus 1? 9/4 minus 1. What's 2 divided by 9 over 4?
8, 9.
Yep. 8, 9 minus 1 equals minus 1 over 9. So once again, you just have to know the formula.
What is the formula saying?
Changing that formula.
What is that formula?
I'm sure it has a name.
So what is this topic called?
It's just or is that-
Let's finish this and then I'll tell you.
He's like, I want to go home. Like,
I'm gonna be studying until like 12 or something.
So when?
12.
Jesus Christ.
I'm really busy too. So what is df equal to?
So the derivative of that is the.
So originally we have f of x that, right? So df with respect to dx is equal to the derivative, which is 2. So what would the derivative be?
Negative 2
Yep. Times.
x plus 1 and then negative 2.
Yep.
So we're trying to find d of that.
Oh, so you just multiply it.
Yeah. So d of f is equal to negative 2 times x plus 1 to negative 2 times d of x. And if we wanted to find when x is equal to 1, we plug in 1.
Like it's 1.
No, 1 second. Yeah, like the information that I gave you is given. Whatever I wrote at the top is given.
Oh, 1/4.
Dx is 1/4.
Mhm.
So it's negative 2 times 2 to the negative 2 power times 1/4. Okay? That's negative 2 all over 4 times 1/4. What does that equal out to?
Negative 16 is
Let's call on Sarah. You're Sarah. Yes, Sarah. Negative what? 1.
Oh, did you plug in 1 for x because that's x not?
Yeah. And then all right up here. Are you guys good with this?
Yeah.
No?
I'm right with it.
I need the upper board.
Okay.
Because now we get to find the error. The answer was negative 1/8 squared. Df. What is the formula for error? That's not the formula. It's change in f minus df.
Okay.
So that's equal to what?
Negative 1/9 minus negative 1/8.
Okay.
Okay.
So negative 8 over 56. Not 56. 72 plus 9 over 72. Right? So your error is within 1 over 72.
You basically just need to study and memorize what's supposed to do.
Like make a note card or write everything on a paper. And I'll put up a review thing that my previous SI gave us with all the formulas and stuff.
Thank you. The error, the delta F and df. What would they say? What is? Oh, find the error, and they would have you. Would they like kind of help you walk with you a little bit and say find delta F and then find
Yeah.
df?
Yeah, that was A, B, and C. It's all about knowing the formulas. And then I'm sure, well, you guys should on your own be good with finding y prime or like cotangent of x squared plus y squared or something like that. Like taking the derivative of those with the chain rule. That's pretty much it for that SI section.
Thank you.
Bye.